Today we'll be speaking about MLOps for enterprise. If that's not what you're looking for, you are in the wrong place. At any point in time in this presentation, feel free to throw any questions in the Q&A. If you're watching on LinkedIn or Twitter, you can also comment your questions there, and we'll answer them when it makes sense. So like I said, today we'll be talking about MLOps for enterprise. Um, So let me start a bit with myself. My name's Simba. I am the founder and CEO here at Featureform. At Featureform, I've had the experience of working with and seeing what many different enterprises do for MLOps. And so I'll be sharing a bit of kind of general best practices I've learned and how I think, or I guess my takeaways from what works and what doesn't work at enterprise. Before Featureform, I ran a team of data scientists. We were doing recommender systems, predicting subscription, predicting churn for over 100 million monthly active users. So quite a lot of data, quite a bit of scale. And we had to build a ton of our own ML platform from scratch. In fact, Featureform was actually built there as an internal tool before we decided to open source it and allow anyone to use it. So the agenda today is first, I want to talk about metrics. I want to talk about what is MLOps, what is the North Star, how can we think about metrics? In an enterprise setting, everything is measured, everything is data driven, everything is driven by metrics. So understanding what our metrics are and how to think about them can go a really long way. Next, we'll talk about the ML lifecycle, um, which will kind of fit into the platform. So I'll be talking and giving my view on how to think of an MLOps platform for an enterprise, what the breakdown is, and how it all kind of comes together. If we have time at the end, I will be able to speak a bit about LLMs, LLM ops, MLOps, how these things come together, how they differ, and how they are the same. Great. So MLOps is just the practice of more or less dealing with building machine learning. It's operationalizing machine learning. Um, and when we learn machine learning, like when we go take a Coursera class or something, everything is super clean. It's really easy. You have a CSV, you train a linear regression on it, you use it to make predictions. That's it. There's no such thing as production. Data is more or less local. And you're not really working with anyone else, and there's no iteration. It kind of just works the first time. Um, Obviously, reality is much better, much messier. Um, in reality, we work across lots of different notebooks, lots of different people, lots of different teams. There's data in tons of different silos and different types of data infrastructure. We'll be generating features and training sets across that data. We'll have data pipelines running in production that differ from data pipelines that we use in our notebooks when we're sampling locally. We'll have features, models everywhere. And so it's no longer this perfect, easy thing when we deal with actual real world use cases. And for that reason, MLOps exists. Um, so MLOps is all about productionizing models. MLOps has really just a handful of goals. One goal is really just getting your models into production, facilitating the process of taking your model and the features and everything that comes with it, the whole system, taking it from experimentation, more or less in the notebook, into production, into a production setting. Um, Secondarily, there's a lot of problems around versioning, reuse, collaboration, sharing, that become really, really critical. Interspersed in those are monitoring, governance, and other sorts of value props. So this is why MLOps exists. And most companies nowadays that have ML teams also have corresponding MLOps teams or ML engineers. I want to talk a bit about how those teams function. I'm assuming that most people here are on those teams or want to join those teams, um, or lead those teams, perhaps even. I want to talk about the metrics, how I think about measuring value in MLOps and how I think about where to go, where to start. So the goal of MLOps, it kind of has three dimensions. There's velocity, throughput, and risk. Velocity is how fast can I get a single data scientist to iterate? How easy can I make it? How many barriers can I remove so that one data scientist can go as easily as possible from what's in their head to actual models, experiments, and potentially even production models? Um, Throughput. In practice, we don't just have a single data scientist. We have many data scientists sometimes, especially at enterprise scale, like data scientists, new data scientists join. Sometimes people leave or they get moved or reorgs happen. And the ability of having high throughput, the ability of many data scientists to be able to work together seamlessly, becomes increasingly valuable to kind of keep the whole team productive. And then finally, there's risks. In an enterprise setting, risk is typically quite high. You're dealing oftentimes with highly sensitive data, and you work in an organization that is likely a bit under a magnifying glass when it comes to their practices with machine learning and data. So the goal of an ML platform or an MLOps team is to make it so that each data scientist can move really quickly, that a group of data scientists can work together cohesively, and that risks are mitigated. So even though they are moving fast, it is nearly impossible. The right risk reduction is in place, the right guardrails are in place so that uh, bad things don't happen. As we're kind of in an interesting zone now where ML ops and ML teams are moving from experimental like teams that were spun up a couple years ago to being pretty core teams that have to drive real metrics. They have to kind of show value. Um, and one thing I like to start with when I think about metrics, especially with regards to ML ops, is that the goal of MLOps, like I said, is to make ML teams more is better, make them have higher output. But if the ML teams themselves are not driving real metrics, then MLOps is useless. So what I mean by that is let's look at something like Spotify. Um, Spotify, one of their teams, let's say, is the recommender system team. These are their metrics. These metrics tie directly to revenue. Um, like you can probably correlate time spent listening to music either directly to revenue or at the very least you can tie it to stickiness. People listen to more music are less likely to churn and therefore you make more money on them. um so you kind of MLOps are a secondary factor of that. With a strong MLOps teams, it allows ML teams to one, accomplish and move their metrics faster, and two, it allows them to, because it's lowering the bar, it makes it easier to solve for problems that might have been impossible to solve for before. So in the end, MLOps in itself is it's a support role. Like you are supporting another team. You're an operations team for the ML team. And I think it's really important to kind of keep that in mind and remember that because in the end, we have a user, we have a customer. Our customer are those data scientists or anyone using our platform. The other set of metrics which are really important, and the one that I think most people think about when they think of MLOps are the more DevOpsy metrics. Deployment frequency, like how easily can we get models in production? How often do we get models in production? When a model is ready, like when I have a notebook, let's say that's ready, I have a new experiment I want to get in production. How long would it take? How much work would it take to get it into production? When things go wrong, let's say my model starts misbehaving, how long does it take to fix that? And then finally, how often is it that my models that I put out actually misbehave or act worse than what's already there? So those are kind of just high level metrics. I want to get into kind of more of the meat of his presentation, which is how to, if I'm running a platform team, um, how I think about building MLOps platforms, especially from scratch, but especially in the enterprise setting. I think the key thing is thinking of your platform like a product. If you think of your platform like a product, everything else kind of falls into place. Like any product person, it starts by thinking about the user. Who is the user of our platform? One thing that a lot of people, at least I personally know that at first I kind of screwed up with, I come from a software engineering background. So to me, a lot of things that maybe my data science team had trouble with were really easy or obvious to me. Most data scientists, as you see here, they come from different backgrounds from software engineers. What that means, and different backgrounds from ML engineers. So the user we're building for is different. Like the way they think, the way they problem solve is different from the way that a software engineer problem solves. Keeping that in mind and who our user is, how they think, and realizing that, hey, what we might want as someone building an MLOps platform and what the end user wants and how they think and what's intuitive to them could be completely different. There are many examples of this, like things that I found data scientists want to be able to control is the logic of their models, transformations, etc. Things that maybe they want to be abstracted away from are some of the intricacies of production, things like scale, etc. Those are not things that most data scientists are originally trained to work on, where most engineers very much so. What we're really trying to do for them is solve cognitive overload. And what that is making it so that they have to keep as little as possible in their head. Things are just easy, they're in flow. It's hard, like they don't have to think about 100 things at once when they're getting them all in production, they're iterating on their machine learning. Um, so our goal is to solve cognitive overload for those data scientists. Um, Now, like I said, what might not give us cognitive overload, or me as a software engineer, cognitive overload may very well be far overcomplicated for a data scientist and vice versa. If we are thinking about, as a software engineer, most software engineers, if we are thinking about distributions, how distributions change over time, all those sorts of problems might be a bit overload to think about versus data scientists, it will feel very natural. So that's one problem that we're aiming to solve. So understanding our end user and then understanding what is overloading them. What are the details that they have to think about that they don't want to be thinking about, and how can we remove those or abstract those away? By taking these ideas, we can really build our pyramid of concerns. So this is really taking together everything I've said so far and putting it into one image. If I'm building an MLOps platform, the first thing that matters is the lowest level, which is the infrastructure metrics I showed earlier. Those are questions like, if I have a model in production, does it work? Does it scale? Is the uptime good? How's the latency? Those sorts of problems. If my MLOps platform does not solve that, like if I can't get a model in production, that model does not solve for those very simple metrics, those base metrics, then who cares about anything else, right? Like it's just not useful, not usable. So that's step one. Just make sure that the model or the system makes it so that the ML system as a whole works. The layer above is this is where we start thinking about iteration and delivery. We start thinking about how fast are data scientists moving? What is the iteration time? What does that cycle look like? How fast is that cycle? That becomes a second layer. So once we make it such that, hey, this ML platform works, like it solves our specific problem, we can actually deploy a model in production with the necessary metrics. Then the second is, cool, how can we iterate on that faster? And then the final piece. There are many things that work in theory, right? Like, yes, like, hey, this thing technically removes these steps from iteration. But as I've found, a lot of MLOps platforms are painful to use. And data scientists will actually go, or ML engineers, whoever end user is, will actually go out of their way to avoid the platform because it's the wrong abstraction in some way. It's either too complicated or not flexible enough. And you end up with kind of people not actually using the platform, which ruins the whole point. So the final thing, once you are able to show that, hey, this thing solves our latency, throughput, uptime needs, two, like it's removing steps, it is actually, we can show that this thing drops risk, increases velocity, makes it easier to deploy things, makes it easier to iterate. And the final piece is it natural to use for my users? If all three of those things are true, we're in great shape. In practice, we typically focus on the bottom two, and we often forget the third one, which I think is the most important one, which is thinking about our platform as a product, thinking about number of users, how often are they using it, when are they avoiding it, why are they avoiding it, etc. So these are just some more examples of how we can measure success of MLOps. There's the performance and reliability, availability, scalability, like latency, number of incidents. There's user satisfaction, things like NPS, where we literally ask our users, hey, do you like using this thing? Or implicitly, like how often are they using it? And then product metrics, which are very, very implicit, like how many people are using this every week? What's their adoption? What's their engagement like, etc. These are things that we should be measuring to make sure our MLS platform works well. A lot of people aren't. A lot of people kind of are focused on more of the nuts and bolt metrics, like how fast is this thing? What's the uptime? And they kind of forget about in my opinion, the whole point of MLOps is to enable a team. And if a team is not using it or does not like to use the platform, then we are not doing our job. Okay, let's start talking about the platform and breaking down the platform. So I've spent a lot of time so far talking very theoretically, how to think about MLOps, how to think about the metrics, how those metrics come together. Now I want to make it a bit more tangible. I want to talk about the actual tools and practices. So MLOps, I already talked about the goal of MLOps, which is to make it easier for teams to deploy, iterate on models, um, collaborate on those models, to monitor those models, etc. In a sense, I'd pretty much say MLOps is a set of tools and practices to automate and streamline the ML model lifecycle from ideation to production. So let's begin by breaking down what the ML model lifecycle means here, and then we'll go to the tools and practices. So the ML model lifecycle, as I see it, is four different modes. There's the data mode, model experimentation mode, deployment, and then monitoring and evaluation. The data mode is I would say one of the usually the first piece and the core piece. We take the data we have, we understand it, we play around with it, we try to pull signal out of it, which is more or less this feature engineering. So that's the first stage of ML, where we're very much in data mode. The tools we use for working with data are going to be very different from the tools that we use for like monitoring or deployment or model experimentation. They're just different. Like, for example, we might be using Databricks here, but for model experimentation, we might be using MLflow or something else. For deployment and monitoring, completely different tools and completely different problems that we are solving. Model experimentation is all about hyperparameter tuning, training models, looking at experiments that we've run, understanding those experiments, actually training the model itself on the data that we generated. So where the first piece is very much just about the data, second piece is very much just about the model. Well, once we have features and models that work, then we need to deploy them. Deployment is about moving these models and feature pipelines in production. In an enterprise setting, this isn't just as simple as just Dockerize it, throw it in a container. Typically, there's much more complexity here, which we'll obviously get into. And then finally, our job's not over there. Now that the model is in production, We need to understand what it's doing. We need to see how it's behaving. We need to see where it is succeeding and where it is failing. And that is monitoring and evaluation. Great. Let's keep moving. I'm going to do a quick aside. I don't want to go super deep into this, but it is relevant, and I did mention I will talk about the platform. One of the base, let's call it like the IDE of data science, is a notebook. And I think sometimes we don't spend, at least some of the teams I've seen, we don't spend enough time thinking about how to manage these notebooks. A lot of people just work locally. They have their own Jupyter server or Jupyter notebooks that they use locally, which is great. It's what a lot of people do. The problem there is no source of truth. There's no centralization. Sharing includes sending files over Slack or something. Where we look at things like the other problem there also is the environment is not standardized. So what maybe my notebook works on my computer, but it won't work on your computer. There are other ways to solve this, like notebook servers. There's things like Colab that kind of solve those sets of problems. There's also different types of things, like the top are very focused on Jupyter notebooks, but there are other types of notebooks like Hex and DeepNote, which kind of add more bells and whistles to the general Jupyter Notebook IDE. So I think it's really important to start there as you're thinking about a platform. Okay, let's come back to thinking about the platform, thinking about building an enterprise MLOps platform. So I mentioned the stages of the lifecycle on the right. I'm going to spend the next large portion of this presentation talking about the layers of abstraction on the left. Because if I put these things together, I end up with my like the breakdown that I've come up with on what the components of an MLOps platform are. This is generic. It's not just an enterprise thing, but obviously for enterprise, you're much more likely to kind of fill in all these boxes, and there's usually a lot more complexity. So even though this framework that I have here that I'm going to present works across startups to large companies, I'm going to be really focused on the enterprise case. Let's start with layer 0 and 1, which is our hardware and compute frameworks. So hardware is, it could be abstracted away from you. You could be just using like EC2. Compute frameworks are typically above that, like Kubernetes would be a compute framework. If you use any of the serverless tools, those are compute frameworks. You could argue that Ray is a compute framework and some of the other types of things. So really it breaks down, I view as there's really two options here. There are the cloud providers and then there are the service providers. The service providers like Vercel, Modal, Banana Dev really remove even the idea of the server isn't really an abstraction there. Obviously, nothing is serverless, but the idea is that you don't think about things as servers. You just think about things as functions and code that runs. Where the cloud providers gives you a much lower level of work. Now, in enterprise, chances are you have some on-prem. Chances are you probably have some hybrid cloud. So maybe you have AWS and Azure, for example. Why this is important is that this all builds on top of each other. So some of the tools in like the upper layers wouldn't work on-prem. So understanding what your compute framework is, what your hardware is actually going to really feed into what you can use above that. For example, if you're on-prem, but you want to use a service which is like SaaS, might not be possible. So I think it's important to kind of start there, understand that piece. Kubernetes, like again, is one of those things that I just think I'm just seeing more and more, continue to see more and more. It's kind of already everywhere. There's been kind of a push away from it, which makes sense. It does add a lot of complexity and a lot of problems. I think in an enterprise setting, though, most people, at least I see, are using Kubernetes, and I think there's value to that. It's just very flexible. And at an enterprise setting, you actually have the problems or likely have the problems that Kubernetes solves anyway. So it's probably not as overkill as it might be for a small startup to use it. Okay, now layer 2 and 3. This is kind of the meat of MLOps. This is where most of MLOps happens. Now, notice that a few things. One is that unlike the layers 0 and 1, the hardware and compute framework layer, these ones are also split up horizontally based on the mode of the ML lifecycle. The other thing to notice is that this is essentially the MLOps layer, but I break it into 2 layers. And that's because I view MLOps problems as 2 categories. There's the engine problem and the workflow problem. The engine problem is all about scale, like compute, like how do I scale compute? I need to serve things in this latency. I need to store this much data. I need to train a massive model that has however many weights. I need to store, I'm sending, 100,000 requests a second, or rather, I'm doing 100,000 predictions a second or something insane. I need monitoring hardware that can actually handle that amount of logs. Then there's a workflow layer on top of that. The workflow layer sits above the engine layer, and it makes it so that it makes it easier. It's a framework for people to work together, to work alone. It keeps things organized. It keeps things clean. It's the framework layer. So there's the engine layer and the framework layer. So let's go through each of the ML lifecycle pieces, and I'll kind of break them down. So the first piece is the data piece. So the services here, or the engine, is where your data is actually transformed and stored. Above it is the orchestration. This is your feature store, how your transformations are run, how they're versioned, how those things are associated to features, how they're associated training sets. This is kind of where feature form lives. We call ourselves a virtual feature store because we sit above these engines. So you can think of it, if you've ever used Terraform, the name feature form, I made it up because I wanted Terraform for features. So a declarative framework to define, manage, and deploy your features. Engine problems. So the problem on the engine layer is how do I serve this much data under X milliseconds? There's dealing with streaming data, processing however much data. The workflow problem, and these are again the things that feature form solves, are versioning, analyzing my features, pushing feature pipelines to production. So kind of dealing with the differences between prod and experimentation, monitoring, lineage, sharing, reuse, collaborating, governance, and all those components come into play at the workflow layer. So I have a question coming. I'm gonna just read it real quick and see. It sounds like it's based on this. Serving features are required. Where are features and feature processing rules usually stored in the platform? Yeah, good question. So the question, I believe, let me know if I'm maybe misunderstanding it, is where in this breakdown, or how can I think about where the actual feature logic lives? And it's actually right here. It's in the workflow. There's different approaches to this. The approach that we take, that feature form takes, so I'm just saying that because it's not going to be the same for every feature store. So I'm talking about us specifically. The approach that we take is that you define your feature as the transformations, the actual logic. Then we apply that logic on top of the infrastructure. So then if I look at a training set, I can understand, okay, here are the steps, the jobs that ran that built this training set. Here's the logic, the SQL queries or the data frame code that built up into this training set that I use to train my model. So when it comes to feature serving, and all the components around like defining the features, that would live in layer 3 of data. Actually, running and storing that data is in layer 2. So layer 3 kind of feeds into layer or rather, the data piece kind of feeds into experimentation because you need to build training data to actually experiment on and to train your models on. It also fits into deployment, which is deploying your model for production. So it is kind of a catch-all. It is a kind of a broad um, category. We do have other talks that I give are very focused on building a feature platform, where we go way more into detail. So a bit of it's kind of out of scope for today. But if you have more questions about it or want to go deeper, feel free to reach out or join our community. I can answer more questions. Um, awesome. Let's move to the next stage. So the next stage is the experimentation stage. So there's, again, layer 3 and layer 2. What does this look like here? Well, there's a training service, which is the engine. This is where you deal with distributed training, perhaps hyperparameter optimization, grid search, that sort of thing. This is like literally like how do I scale, up to n GPUs so that I can train this massive model or this massive set of models. Then there's the workflow problem, which is, okay, well, I've now run 100 experiments in my grid search or whatever. I want to understand all those experiments. All those experiments probably generated models, artifacts. So I need to track those artifacts in some sort of like model store. I want to also be able to compare and contrast those experiments so I can understand what's happening in each of them, which one's best, and what the kind of drawbacks of each of them are of their behavior. So it's the same thing. There's the engine, which is like I need to, it's like a black box. Like I give it a model and maybe a data, and then it pops out a trained model. That's great, but then I need to build a workflow on top of that to handle versioning and management and tracking and model store and UI to compare and contrast and all that stuff above it. And that's a workflow problem. So this is kind of where like MLflow lives, is the workflow level. For the engine, there are lots of tools there, like DESI and other things, which are just entirely focused on training models. Once a model is trained, you have to start dealing with serving. In many settings, a model has to actually be, once it's trained, that's not it. It has to get deployed. Some models are online, which means that they are deployed in a setting where they can, like a recommender system, where they're kind of constantly being bombarded with requests. Other models are offline, where they run in batch, which usually makes deployment much easier. Most of the deployment is focused on online models. That's where it becomes way more complicated. Offline models, there's still work to be done there, and there's still like a lot of complexity. Like, how do I run, especially if it's a large model? How can I run that across my large table of rows? For online though, it can be much more complicated because you are dealing with I guess with scoring in offline models, the model turns on and off. In online setting, the model's never off. It's always there. It's always running. Updates have to happen without any downtime. So in the deployment, there's the engine, which handles scalability, uptime, latency. The engine is typically the single node, like just like running one instance of the model. There's a lot of different ways that we package our models, that we run those models. We can quantize things. Excuse me. Sorry. So we can quantize things. And that's the engine. Now, in practice, we might have multiple models deployed at once. We might be doing A/B testing. We might need to upgrade the model. So we have a model, we created a new version of it, we trained it, it seemingly works better. We want to upgrade to that new model. Sometimes new upgrades fail, like the model actually does worse in production. We have to downgrade again. To solve that, sometimes what we'll do is so that we don't constantly deploy models that actually work worse in production, we'll run canary deployments. which are kind of like A/B tests, or it's like a form of A/B testing in the sense where we deploy a model only to like 1% of the population and see how it behaves. If it behaves well, then we can kind of scope it up. And if it misbehaves, then we can kind of cancel that with minimum impact on users. Um, so the workflow layer, there's tools like Selden Core, there's tools like Base 10, there's tools like Yatai that solve the workflow problem, which are very much about kind of the upgrading, the keeping, even just keeping track of what's deployed in production, how different, like what tests are running, what different models are running, maybe attaching those to the MLflow type layer. All that stuff gets solved by deployment. Finally, there's monitoring. Once the model is in production, we need to understand what it's doing. Also nicely falls into two layers. There's the engine, which is a one-piece storage, which is storing the logs, because to do monitoring, you need to store what the model, kind of what was input, what did it predict. So the features and the prediction. So you need storage for that. You need something that can store a lot of that information very quickly. You also need to be able to analyze that. And you can't, just storing it might be useful in some sense, but really the whole point of doing these logs is to analyze them and understand what they're doing. Now, if I just give you a Redshift table or a Snowflake table full of logs of predictions that my model has made, that might be enough. But in practice, you probably want to build workflows on top of that. You want to build alerting. You want to build some form of explainability. It's not just, a black box, like being able to maybe get a little bit smarter about correlations, maybe figuring out what data points break my model, visualizing those things. I like to frame the workflow as painting a picture. Like you're really trying to take what is just really dense data of predictions and turning it into a very clear image of what is happening in production. So there's a question of, are log files stored as text files? They definitely not text. Text would be unusual. There are different ways to store it, and it's going to depend on the tool you use above it. Some people will just use like an expensive but easy way is like Snowflake, where you just append into some sort of like ELT. What's maybe more common is maybe putting all those logs into a Kafka stream and then maybe logging those into S3, which won't be a text file in a sense, but it will be a file, likely some other format, which is a bit more like a Parquet file maybe, or even maybe a table if you want to use something like Iceberg or Delta. So that's what we would use there, and then the analysis runs on top of that. The reason for that is just those other formats are going to allow for, one, it's going to be more compact, and two, it will allow for more efficient analysis. Good question. Thank you. Great. That's how it all comes together. Now there's one final layer, which is the platform layer, which is layer 4. The way I think of the platform layer is there are these engines, these black boxes, which I talked about. That was like the layer 2, like Spark and Redis and those types of things. We fit those together into workflows. So there's the data workflow, there is the evaluation workflow, monitoring workflow, there's the deployment workflow, there's the experimentation workflow, and the training workflow. So there are 4 workflows. Now they're distinct, right? Like the tools you tend to use in those 4 workflows are very different. But kind of the mark of a fully, in my opinion, like a really high quality, MLOps platform is when those workflows also kind of work together. For example, in experimentation, if I look at an experiment, I want to be able to look at the data it was trained on and then go into the feature store and understand what that is, how that training happened. Like what is that, how was that data set generated? If I deploy models and I have an A/B test running, In my deployment, I should be able to see the A/B test. It should be easy for me to get to my dashboard that's showing the comparison in my evaluation. It should also be easy to show those models in the model store so that I can see the models that and how they were trained and what high parameters they use and what data they use. So essentially, it unifies all these workflows into one cohesive thing. That's layer 4, which is the platform layer. This is the layer that's going to be most custom. And in my opinion, this is the layer that most people should build from scratch. Um, there are tools, obviously, that build these things for you. For example, the Kubeflow gives you a strong generalized version of layer 4. And a lot of people, places I see people build that sort of stuff from scratch as well. There's no right or wrong answer, like for all of this stuff. The answer is going to really depend on your problem statement, your company's culture, amongst other things. The other thing that I want to make sure is a good takeaway from this platform thinking is finding and choosing the right layer for the problem you're having. If you're dealing with problems, getting your data pipelines, versioning those, getting those in production, then you are dealing with the data column. And then the question is my problem latency or the tools I use to compute the data, or is the problem in the workflow? If the problem's in the compute, maybe you use Redshift and you should move to something else. If it's in the workflow, then maybe you don't have a workflow and you can consider something like feature form. This applies across the different layers. So this will kind of help you break these things down. This is by no means a complete list of companies. In fact, it's just a handful that I kind of off the top of my head came up with when I put together this slide. For APIs. So there's a question, what tools usually used to model call for APIs in enterprise? So I think the question is more related to deployment, which is like, how do I put that model behind an API? Let me know if I'm misunderstanding that. That would be in the deployment and serving, and it would be in layer 2 and 3. There's a few examples here. There is 3 that are top of mind. 1 is Selden, 2 is Bento, and 3 is Base 10. I think all 3 of those products are great. They're all very different. So if I was looking to solve that problem, I'd look at those 3 products in particular. Great. Okay. I want to just do a quick aside on LLMs. So, excuse me. So for LLMs, it's a hot topic, some might say. How are LLMs? How is it changing things? How does it affect MLOps? So one thing I've found, there's kind of one is that with models in particular, with LLMs, they work pretty well out the box. Like if you just ask ChatGPT a question, it will give you a pretty decent but generic answer. A lot of focus on LLMs and LLM systems, base systems, is getting and injecting data into the LLM so that it can behave better. There's 2 ways to do that. There's fine-tuning and RAG. Both have their pros and cons. I'm not going to go super deep into those, but I will quickly describe what RAG is. So RAG is contextualizing our prompt of data, which means that a user asks a question like, how should I be, let's say you're a bank, and the user asks, how should I be investing? You might want to grab some of their analytical features, their age, their money that they have in their bank account, their average spending, their spend categories, their risk factor. Maybe you have other models like credit score, which feed features. You might want to retrieve relevant paragraphs from your blog, or maybe you have a set of your wealth manager conversations recorded and you want to grab relevant sections of those conversations. You take all of this information, this data, and then you fit it into your prompt. So given the user has these attributes and using the context from a blog, answer this question. And LLM will do a much better job in practice by using this information, by using this data. So this is RAG. my view is that MLOps and LLMOps merge because the problem spaces are almost the same. There are things that are different. For example, prompts are exclusively a LLM problem, where in MLOps there are things like hyperparameter tuning, which this looks very different than it would look in LLMs. So it's not exactly the same. So not everything's one-to-one, but there is a huge overlap. With LLMs, if you look at the kind of bottom layers, the first piece is taking your data, making it usable, understanding your data. There are slightly different tools sometimes used here, like vector databases, but most of it's more or less the same. Model experimentation and training. This kind of becomes fine-tuning in this example, and it's actually not required. It's a bit different. Deployment and serving. If you're using ChatGPT, it's handled for you. If not, then it's kind of a different problem. And then monitoring evaluation is still a core problem. I want to really highlight that the data piece and the monitoring piece are core issues in both situations. I don't think GPT is the end of traditional machine learning. I think it's very far from that. I think it becomes a very powerful tool in our tool belt. There are different problems that really orient towards different use cases. So for example, like fraud detection tends to orient well for traditional machine learning problems. So the main takeaways I want you to have from this talk, one is the key metrics, like thinking about metrics, understanding what MLOps, the point of MLOps is. I think we just sometimes get too caught up in the weeds and we forget to zoom out and look at what the whole point of the MLOps platform is, who our user is, and how we should measure our value to them. Two is that the MLOps platform is not, it's actually more structured. There is a kind of a set of tools and a way to think about them that starts with the ML lifecycle. Three is that LMOps and MLOps are highly related, and you can actually kind of invest in both. I don't really view them as separate platforms. I don't think it makes sense to separate them. And I've actually already seen this in practice. Many companies I talk to are doing both together. Awesome. Well, that's all I have for you today. I hope this is useful. There was a good set of questions that came in. If there are any last questions, feel free to ask them. Otherwise, I'll hand it over to Marie to do a sign off.
All right. Yeah, I don't see any questions on LinkedIn. Last call for any questions for Simba. But otherwise, so after this webinar, I will send you guys a little follow-up email, which will contain the recording for this webinar. It'll also contain links to our Slack community and our docs to give you more information about how to use Featureform. But other than that, thank you guys so much for attending our webinar. Also, in the follow-up email, if you have any feedback, don't hesitate to reach out to us. All right.
Thanks, everyone.
Yes.